Hey guys, these are the notes on 11.2. The topic is called permutations. Don't forget that word, permutation. It's just a word to also kind of refer to how many outcomes there are, how many different ways this can be done. But it's one where the order in which I pick things matters. So, for example, maybe how many different ways can I pick 3 pens from from all the pens I have? Could be one set of 3. Let's say, how many different ways can I pick 3 pens from the pens I have? Let's say I have 20 pens. How many different ways can I pick 3? Well, that might be different if the order matters. Meaning, if I'm going to pick these pens and take them with me to school and the order doesn't matter, that's one thing. Just going to take the red, green, and black pens. However, if it was a permutation, the order in which I pick them would matter. It would be like, what is my favorite pen? Oh, maybe my favorite pen is this one, the black one. And what's my second favorite? The red. And then my third favorite is the green. So try to process that. Does the order matter, right? If I put them in order from my favorite, second favorite, third favorite, then the order matters. If I just say, oh, I'm just taking these 3 pens, then the order in which they are placed doesn't matter or picked. So again, try to keep that in mind. The permutation is an ordered arrangement of items that occurs when no item is used more than once, and the order of the arrangement makes a difference, the order in which it gets picked or placed. Okay? You need to understand how to evaluate a factorial. A factorial is a number with an exclamation point, and you could see how it's defined. It's defined as, like in this case, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And here the technical definition, it's a factorial is a product of all the positive integers of that number and below. So whatever number it is factorial, it's always multiply that number by each integer that's less than it, all the way down till you get to 1. So let's go ahead and read example 2 here. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? Well, this is just like I was saying. It's basically, again, since it's 7 books, it is going to be 7 factorial, because it's just going to be, if you think about it, you're going to put your 7 favorite books in order. When you pick the first book, you have 7 options. When you pick the second book, there's only 6 options, right? So each time you pick a book, to put in order from your favorite to your second favorite, third favorite, and so on, each time you pick one, there's one less book to choose. So 7 factorial. Your calculator may have a factorial key, but if it doesn't, you could just multiply it out. So if you multiply all this out, you should come to the conclusion, 5,040 ways to arrange the 7 books. 5,040 different ways that they may be ordered, from most favorite to 7th most favorite. And how many ways can you arrange 5 books along a bookshelf, assuming the order makes a difference? Once again, this is 5 factorial. So 5 times 4 times 3 times 2 times 1. This one maybe you could do by hand. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. Right, so you might want to take a read of this right here. It just kind of explains it again. Here, this is what you're going to notice with these factorials in the next little section. They're fractions. They're set up as fractions because we want to make sure we work through this skill before we do the next couple problems. Alright, so as far as 1 factorial divided by another factorial, I'm only going to write this one out because normally, let me see. So 8 factorial, right? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial. So basically the smaller factorial is going to cancel out. The lesser factorial is going to cancel, right? If you expand it, you can see why. The 5, 4, 3, 2, and 1 all can cancel. And then all I have to multiply is 8 times 7 times 6 to make this calculation. 336. So I would just say cancel the lesser variable. Don't write it all out. Cancel the lesser factorial. So 21 is lesser, which means 26 times 25 times 24 times 23 times 22 would still have to be calculated, right? Once I get to 21, everything from 21 is going to cancel. So again, the lesser factorial is going to cancel. And as far as the larger factorial, we'll also need to multiply everything before or greater than that lesser number. So let's see, 26 times 5 times 24 times 23 times 22. Looks like 7,893,600. Again, this is kind of a build up to this is just skills with factorials, but it's so that we can do these skills once we have to calculate using, well, you'll see there's a little something of a formula we have to use on the other side. Here, 499 is the lesser, it's going to cancel. Here, all I'm going to have left is 500. Everything from 499 down is going to cancel. Again, the lesser factorial, it's going to cancel out on the top and the bottom. Here, 6 is lesser, it's going to cancel. I'd still be left with 9 times 8 times 7. Stop there, right? 6 cancels, so make sure you don't put the 6. 9 times 8 times 7, let's see what that is. 504. Here I would cancel out the lesser, 11 factorial, leaving me with 16 times 15 times 14 times 13 times 12, right? Anything from 11 down is canceling. That's 524,160 on that one. Here, everything from 99 down is going to cancel, leaving me with just 100. So that's how I would do those, again, with the canceling of the lesser factorial on the top and the bottom. Okay, so these problems are permutations also, just like the ones on the front side where we were picking putting our favorite books in order. The order matters. On this next example, the order matters also. When you're picking, it says, you and 18 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. And here's what it means as far as the order matters. It matters whether I get picked. Let's say I get picked. If I get picked for the CEO, my job duties aren't going to be the same as if I get picked as the treasurer. So this is kind of an order matters situation, because it matters which of these jobs I get, because my duties won't be the same. So anyhow, when you're picking, and then when you're picking R things from N things in a permutation, in this case we're picking 3 officers from 19 total people. Again, you and 18 of your friends, 19 total. But we're only picking 3 of those people for these 1, 2, 3 positions. So when you are only picking a certain number of people, you have this little formula here. The way it's written is 19p3. It basically implies you're only picking 3 different things from 19 total. How many different ways can you do that if the order actually matters, right? Well, this is the formula. You would take the n number, in this case 19 factorial, and then put it over n minus r, so 19 minus 3 factorial. So you see how this applies kind of to those problems we were doing at the bottom of the front side, right? Because this 19 minus 3 is 16 factorial, and now it looks kind of like those problems where the entire lesser factorial will cancel, leaving me with 19 times 17 times 18. You might say that you could have figured this out without the factorial formula, because you have 19 options for the first pick, let's say. And, oh, why did I do this in that order? That's so weird. Anyhow, then you have 18 options for the second pick, and then only 17 options. So you could have kind of followed the lead from yesterday. It's just that the permutation formula gives us another option for these. 5,814 different ways to pick those 3 officers from the 19 people. Corporation has 7 members on its board of directors, and how many different ways can it elect a president, vice president, secretary, and treasury? So 1, 2, 3, 4. From 7, we're picking 4 from 7, so this is 7p4. And if you look at the formula, you can see that it's going to be 7 factorial divided by 7 minus 4 factorial. And again, these, be careful with these, right? They can be a little tricky as far as setting up and getting it all right. So 7 minus 4 is 3. That means basically the 3 factorial is going to cancel on the top and bottom, leaving me with 7 times 6 times 5 times 4. Let's see what that is. 840. So from the 7 people, there's 840 different ways they can pick these 4 officers. I'm going to keep going here. Next we have this situation where we're trying to see how many different ways there are to order something, but there's duplicates of certain items. So for example, if I was trying to figure out how many different ways I can order the letters of Mississippi, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters, so it could have been 11 factorial if there was no repeats, but we'll actually have to divide by the factorial of how many there is on the duplicates. So again, let's recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 letters in Mississippi, so how many different ways could I rearrange them? If there was no duplicate letters, it'd be 11 factorial, but since there's duplicates, I have to divide by each factorial being how many there is of a certain letter. So for example, I, there's 1, 2, 3, there's 4 I's, so I need to divide by 4 factorial for the I's. There's 1, 2, 3, 4 S's, so I need to divide by a second 4 factorial for the S's. And there's 1 M, and there's 2 P's, so I need to divide by another 2 factorial for the P's. So I could say, well, you know what, I'm going to cancel out one of these 4 factorials on the top and bottom, leaving me with 11 times 10 times 9 times 8 times 7 times 6 times 5, right? I canceled out the 4 factorial, so make sure you stop at the 5 there. On the bottom, I have 4. I still have another 4 factorial, 4 times 3 times 2 times 1, and I have another 2 factorial, so 2 times 1. And I can actually cancel some stuff here, like I could cancel the 4 with the 8, leave a 2 there. 8 divided by 4 is 2. Now this 2 I'll cancel with this 2. The order in which you cancel doesn't matter, but I'm just showing you can cancel some stuff out here. 9 divided by 3 is 3. I have another 2 here I can use to cancel with this 6. 6 divided by 2 is 3. Now I've canceled everything on the bottom. All I have left is 1s, so I can just multiply to get this final answer. How many different ways can the letters of Mississippi be arranged, given that there's all those duplicates? Well, let's see. 11 times 10 times 3 times 7 times 3 times 5. Let's see what that is. Times 10 times 3 times 7 times 3 times 5. 34,650. ways. And then I can do the same thing for osmosis. How many different ways can the letters of osmosis be arranged? 1, 2, 3, 4, 5, 6, 7. There's 7 letters, but since there's duplicates, that 7 factorial isn't going to be the final answer, right? We're going to have to divide by the factorial for the duplicates. Each duplicate, there's 2 O's, so 2 factorial. There's 1, 2, 3 S's, so 3 factorial for the S's. And there's only 1 M and only 1 I, so we're good there. I'm going to cancel the 3 factorial right off the bat. So 7 times 6 times 5 times 4. Since I canceled the 3 factorial, I can stop there. I still have 2 times 1 here, which I can cancel the 2 with anything, the 6 or the 4, so I'll just cancel it with the 6 since it's directly below it. And now I can multiply it out. 7 times 3 is 21. 21 times 5 is 105. 105 times 4, looks like there's 420 ways to rearrange the letters of osmosis. So hopefully that helps, and definitely watch it again if needed. Thanks for having a look.